You know, our brains are basically pattern matching machines. It's what we do. We see two things happening around the same time, and we just can't help but try to draw a line between them. But what if that line we're drawing isn't really there? Today, we're going to dive into that exact question. What's a real connection, and what's just a coincidence?
Okay, just take a look at this. A scientist finds a link between owning a cat and getting struck by lightning. I mean, it sounds completely ridiculous, right? But it perfectly sets up the big question for today. Just because two things happen in a similar pattern, does that mean one causes the other? So, that common little trip up in our thinking, that habit of seeing cause and effect everywhere we look, that's exactly what we're here to unpack. We're going to explore the powerful tools scientists use to see these relationships and, more importantly, understand its biggest, most critical limitation. And that tool has a name. It's called correlational research. Really, its entire goal is just to see if a relationship exists between two things, like maybe coffee drinking and productivity, and then to simply describe what that relationship looks like. And here it is. This is the single most important thing to remember right from the get-go. This kind of research is fantastic for describing a connection, but it's not built to explain why that connection exists. It finds the pattern, not the cause. That's a huge difference. So, how do we actually measure these relationships? Well, we don't just squint at the data and say, yeah, they seem kind of related. Nope. We have a very precise mathematical way to measure both the strength and the direction of the link between two things. And that measurement is called the correlation coefficient. It's just a single number, but wow, does it tell you a lot. It always falls somewhere on a scale from -1 to +1, and it packs a ton of information into that small range.
This whole spectrum is the key. All the way over on the right, you have a perfect positive relationship at +1. All the way on the left, a perfect negative relationship at -1. And right there in the middle, at 0, that means there's absolutely no relationship at all.
Let's zoom in on the right side for a sec. A perfect positive correlation, a +1, means that as one thing goes up, the other thing goes up in perfect lockstep. See how the dots form a perfect straight line? Think about it like this. The more hours you work at a set wage, the bigger your paycheck gets.
Now let's jump over to the other extreme. A perfect negative correlation of -1 is the total opposite. As one variable goes up, the other goes down, again in a perfect straight line. A great example is the gas in your car. The more miles you drive, the less fuel you have in the tank.
And then there's the middle of the road. A coefficient of 0 means there is no pattern at all. The dots are just a random cloud. There's no connection between the variables whatsoever. Kind of like the relationship between your shoe size and your IQ.
So if we boil it all down, the crucial point is this. Positive correlation means the variables move in the same direction. Both go up or both go down together. Negative correlation means they move in opposite directions. As one goes up, the other goes down. Simple as that. Okay, let's apply this to a really fascinating real-world example. If you look at the relationship between income and weight, the data tells two completely different stories depending on who you're looking at. For men, on the left, there's a positive relationship. As income tends to go up, so does weight. But for women, on the right, it's a negative relationship. As income goes up, weight tends to go down. Isn't that wild? The exact same variables, but opposite correlations?
Okay, so right about now you might be thinking, if it doesn't prove cause, then what's the point? That's a fair question. And the answer is that even without knowing the cause, knowing the relationship gives us an incredibly powerful tool, the ability to predict. And we use this power everywhere. If we know that high school grades are strongly correlated with college grades, we can predict who is likely to succeed. We use it to make sure tests are valid, like do SAT scores actually predict college performance? We use it to ensure measurements are reliable and to test if our biggest scientific theories hold up in the real world. It's a foundational tool of science.
Which brings us to the main event, the grand finale. We're about to cover the single biggest mistake people make and the one rule you absolutely have to remember to become a much sharper critical thinker. Let's just put it right out there, clear as day. You can even say it with me. Correlation does not demonstrate causation. Just because two things are related does not mean that one causes the other to happen, period. Let's put this rule to the test with a classic example. It is a fact that there is a strong positive correlation between ice cream sales and shark attacks. The more ice cream that gets sold, the more shark attacks are reported. So, does this mean eating a scoop of ice cream somehow makes you a shark magnet?
Of course not. The real answer is something else entirely. There's something hidden in the background that's influencing both of those things at the same time.
This is called the third variable problem. In our example, that hidden third variable is just hot weather. When it's hot, more people buy ice cream, and when it's hot, more people go swimming in the ocean, which unfortunately just increases the odds of a shark encounter. The heat causes both, not the ice cream.
And there's a second trap, too. It's called the directionality problem. Let's say we find a correlation between aggression in kids and watching violent TV. Well, does watching violent TV cause aggression? Or is it that kids who are already aggressive are just more likely to choose to watch violent TV? The correlation itself can't tell us which way the causal arrow is pointing.
Look, understanding all this isn't just some academic exercise. It's a fundamental skill for navigating a world that's constantly throwing news headlines, ads, and data at you, all trying to convince you that one thing causes another.
So let's bring it all together. The real power of correlational research is that it lets us observe the world as it is, finding real, predictable patterns in how things naturally happen. But its great weakness, the thing you have to burn into your brain, is that it can never, by itself, tell us why those patterns exist. That's because of those pesky third variables and the mystery of which way the cause and effect arrow points.
And here's one last really powerful way to think about this. A very strong correlation, let's say 0.8, doesn't mean it explains 80% of what's going on. In statistics, you actually square that number. So a 0.8 correlation means we can predict about 64% of the outcome. Now that's incredibly useful, but it also reminds us that over a third of the story, 36%, is still completely unexplained. Correlation gives us clues, but it never gives us the full picture. So, I'll leave you with this thought. Knowing that good grades in high school can predict good grades in college might influence your choice to study more. That's using prediction in a powerful way. But when might a prediction, even an accurate one, actually limit you or someone else? And how can you use this knowledge to start questioning all the connections you see every single day?